Welcome, everyone. My name is Laurent Pertois, and not Jamf Seed. I'm a senior professional services engineer with Jamf. And today we're going to talk about, as we said, compliance and identity. Yep. So the agenda for today, we're going to have a bit of history about cryptography, because when you talk about certificates, you need to talk about cryptography. Otherwise, it makes no sense. We're going to talk about the DigiCert Integration, which is a brand new thing from 10.16, and we're going to deep dive into the ADCS Connector. Who is using the ADCS Connector here? Cool. I think you're in the right session. So a bit of history. For a long time, our humanity has decided that exchanging and communicating in clear was not always the best thing to do. So they tried to invent a bunch of different ways to hide their messages so that, for example, especially at war, so military are the specialists about that, especially at war, when you send a message to your troops, your enemy cannot read it. And one of the very first way to hide a message was the sital from the Spartans. I don't know if you've ever seen that. So the idea is that the sital is the piece of wood, and you roll your piece of leather around it, you start to write your message, then you unroll it, which makes that it's unreadable if you don't have the correct piece of wood. And you can carry that, I don't know, as a belt or whatever. Then we had a guy called, I hit this remote, Caesar. Who heard of Caesar? Julius Caesar? Okay, so it's not easy to find a picture of Caesar, but managed to find one. They say he looks like this. Can't really say. And Caesar invented a cipher, which was called the Caesar cipher, where basically, I'm pretty sure you've all done that in your life, at least especially when you were a kid. The idea is that you take the alphabet and you shift it, let's say by a certain number of letters. The big classical one in computers is by 13 letters when you use the Roman alphabet, which is also called the ROT13. And then you look at the letter you want to write on the upper alphabet, and you look at the same letter just beneath, just under, to get your message. And for example, when you want to write apple, you're going to write C again, because P, and then for the L, it's going to be a Y, and then you're going to have an R. And you get your crypted message. Great. And if you don't know by which number of letters you've shifted, you have a secret message. You can also make some variations by starting the second alphabet with a special word like Jules César, because I wrote this in French, so it should be Julius. So you take the letters of the name of the word, and then you start shifting everything else, and you go on. Same thing, just a variation. The big problem of that kind of cryptography is that it's very weak, because each letter is always using the very same in the second alphabet. So if you look at Apple, we have two letters that are identical, which represent the P. So by doing some statistical analysis on the long text, you might say, well, I can see that this letter is coming very, very often. What is the most common letter in English? E. Let's say that this letter that I see a lot is the E. In our case, it wouldn't work, but it's only one letter, one word, but on the long text, it can work. Then people came with some more advanced things. We can take this French guy, Blaise de Vigenère, who in the 16th century, he was a diplomat, but decided to create some kind of cipher using a square. So you have your letters at the top, you have a second set of letters on the side, and then you have all the variations of the Caesar cipher. And then you have your alphabet, and then you have your secret key. So you choose a secret key with someone. Let's have a look at what it looks like. So the clear text is going to be apple once again. My secret key, as I'm French, I'm going to use poire, which is pear. Good thing is that it's the same number of letters. So let's try to convert our text. So if we take the A, and the A is the first column, we go to the P row, we get the first letter. Then we're going to go to the second letter, the first P of apple, P. The next line is going to be the O for poire, and it's going to be a D. And then we go on, and we said that this time, the two P's are not represented by the same letter. So we break some statistics using that method. And the thing to know is that this system is still considered very solid under two conditions. Never reuse the same secret key, and your secret key must be random and the exact same length as your text. So if you want to encrypt War and Peace, it takes a long time. As an example. Let's move again in the future, and maybe you've heard of this machine, Enigma, that was used by the Germans during the Second World War and a bit before. And that machine is an automated system to do cryptography. That was a big problem for the Allies during the Second World War. So some people started working on that and trying to decrypt the messages from the Germans. And do you know who was the first to do that? Actually, no. But he did a lot. The very first to do that was a Polish guy, a mathematician called Marian Rejewski. Here he is. And he was 23 when he did that, when he broke the Enigma the first time. Then Alan Turing came into place and really, really improved the method and helped a lot. And they created some automated system that looked like this. They were called the bombs, to automatically decrypt the messages from the German during the Second World War. Again, using a weakness, which was the fact that our friends in Germany are very strict about what is the first message they send, which was always the weather forecast, always the same at 6 a.m. in the morning, always starting more or less the same, ending the same. And then there were lots. This is the Colossus also. And so the main issues with all these methods, because they use a system that is called symmetric cryptography. So you have to know the secret or the way to encrypt, and you have to transmit that to the recipient, and you have to transmit that in a very, very safe way, because if anyone gets the key, then they can decrypt your system. So there was a key transmission. At some point, the US, I think it was diplomacy, and the US Army had dedicated agents just to transfer keys between embassies and US base. So then there was the picnic, program in chair, not in computer. What I said about the German, if you are too strict sometimes about what you're sending, it can become easy. And the cryptanalysis, which is, let's try to figure out what they're saying based on some repetitions and things like that. But hopefully, these days, we have modern cryptographic with asymmetric keys. So they're more recent because they're like 40, 45 years. They're based on mathematics, prime numbers. And you have two keys this time. One that is private, one that is public. And it makes the transmission way more easy because you can transfer your public key to anyone without being very careful, at least a bit, but not as much as if it was the private one. The thing is that your private key, the public key, can only encrypt a message, but cannot decrypt it. What can decrypt it is your private key. So let's have a look at what it looks like. So here are Alice and Bob, because in crypto you always use Alice and Bob. And they want to start sending messages to each other, and Bob wants to send a message. So Alice is going to send a public key to Bob, and we're going to use a lock for that. And Bob is going to write a message, encrypt it using the public key. Now Bob cannot read it anymore. Great. And send it to Alice, and Alice, using a private key, is going to be able to open the message and read it. The very first people who started to work on that were Diffie and Hellman. You may have heard of DH sometimes in crypto. And also Rivas, Shamir, and Adelman, RSA. So far, so good? Now let's talk about certificates. Who is using certificates? I should see all the hands. Those who didn't raise their hands didn't listen. So what is a certificate? Who can describe a certificate? Good question. We all use certificates. We don't really know what they are. It's kind of a magic box. So a certificate is something that is either mainly your identity. It's proving who you are. That's when you go on a website and you see the little green padlock and it says, click on that. Oh, it says that it's www.apple.com. Let's have a comparison because we talk about identity. And what is the best example of an identity when you travel? Passport. So if we look at a passport and a certificate, we're going to see a few things that are identical. First, we all have a name. Well, on our certificate, there is a common name. We also have different names on certificate. I don't want to go too deep. Then there is an issuer. Who gave you your passport? Your country, usually. Or a man in the street, but that's a bit different. Well, it's the same for your certificate. Your certificate is issued by someone, and in order for this to work, we need to trust both. Either of these. We need to trust the issuer for your passport, and we need to trust, we need to trust the issuer of the certificate. But there are also validity dates. So a certificate is valid from a specific date and not valid after a specific date. Guess what? Passport do the same. They're valid when they give it to you, and not valid after, what is it, 10 years? Yes, 10 years. And they also have a serial number. Well, this passport has an easy serial number. It's not a fake one. It's an example one that I found on a very official website. Do not search for passport scan on the internet. This is awful. People put their passport on the... well. So, see that there are some similarity. Certificates were not created out of the blue, like, oh, let's create something, but make it different. No, let's reuse what we use in the real life. And all certificates are based on what we call a PKI, private key infrastructure, and all these rely on a trust. As I said, we trust the issuer. We have to trust someone. Someone has to be trusted at some point. There is a hierarchy, and also key negotiations and things like that. We're going to see these. So it all starts with, and you all have these in your Mac, Windows, whatever system you use, the root CAs. And the root CAs are a list of issuers, and they are original certificate that is self-signed, because it has to be self-signed, because it can't be signed by someone else, and that will be used to issue certificates. Not directly, but will be used to issue certificates to other people. So let's say you're going to a website and say, hey, I'm going to www.apple.com, but how do I know that it's really www.apple.com? Let's ask. And so we ask the website, sends us the certificate, we can look at it, we can see that it was issued by a specific certificate authority. We can compare it with the list of known certificate authorities we have in our system that we trust, and say, well, they match. Apparently, I'm in the good place. Usually, it's not directly issued by the root certificate. You have an intermediate certificate or issuer that is used because your root certificate, when you are creating certificates, is your most precious thing. So you don't want to have, especially the private key that is associated with it. You can't lose that. If you lose that, it means that the person who has the private key can create any certificates they want. It happened a few years ago to a company called DigiCert, and very quickly, everyone started to say, we don't trust them anymore. So we can see that hierarchy. Once again, when we look at the communication, we have the certificate, then we have the intermediate, and then we have the root. And when you click on each of these, you can see that every time it's issued by the upper one. So a bit of history. It all started in 1995 with SSL 2 on Netscape 1.1. SSL 1 never existed. This is not the SSL you're looking for. Very quickly, we had SSL 3 because 2 was not really great. And because it was too simple, they decided, hey, you know what? Now that everyone knows the word SSL or the acronym SSL, we're going to rename it. So it became TLS, also known as SSL 3.1. That would be too easy, right? And we are at 1.3, 1.4 is on the list now. Things start to move. But it all came with Netscape. Who remembers Netscape? Who used Netscape? Yeah, we all did. Also, something to know about certificates. A certificate can, of course, be revoked and say, yeah, that certificate is no longer valid. And there are multiple methods to distribute this information. One is called the Certificate Revocation List, the CRL, and also the Online Certificate Status Protocol, the infamous OCSP. Great, done for the history. Let's talk about Jamf and certificates. So now we have a new integration with a product called DigiCert, which in fact replaces Symantec with new settings, well, settings and features. The very big new features is there is an auto revoke. So when the device, for example, your market device has no longer managed or whatever, then the certificate associated to that device is revoked. So it can no longer be used for example, connecting to your Wi-Fi or whatever. And now, let's talk about the ADCS connector, because a lot to say about the ADCS connector. So who is using it? I remember a few hands. Who is using it with the default setup? The very one that when you run the command line and you don't change anything. No one? What am I doing here? So the ADCS connector, a few prerequisites for those who don't know it. It requires Windows Server 2016 or higher. Don't try on 2012, doesn't work. It requires that the server hosting the connector is a member of the same domain as the PKI server, or that there is a trust relation between the domain of the connector, the server hosting the connector, and the domain of the PKI. It doesn't have to be exactly the same domain. It can be two different domains, but as long as there is a trust between these domains, it will work. We'll show that. .NET 4.5 or higher, which is standard on Windows Server 2016. You need an FQDN, fully qualified domain name. Talk about that later. And the port, by default, the connector is listening on port 443. This can be changed. This can be translated. And then for the connection between the connector and the PKI, the certificate server, you're going to use port 135 and 49.152 to 65.535, standard for DCOM. It can also be marked as a specific port. So this is what it looks like. Jamf Pro is going to talk to the connector saying, hey, my friend connector, I would like a certificate for this very specific device. The connector is going to go to your certificate server and say, I would like a certificate for that device with that name, that characteristics. Can you do that? I'm going to use that template. Everything goes fine. We get the certificate. It's transferred back to Jamf Pro. Jamf Pro can now send it to the device. Or the computer, an iOS device, whatever. It's using a standard configuration profile for that. So the simple setup, same domain for the connector and the certificate server. We provide an installer that is a PowerShell script. You may have seen that. So here is our setup. We have a Jamf Cloud server that's food@jamfcloud.com. Then we have the ADCSC.company.com, which is the FQDN for our connector, and the pki.corp.company.com, which is the address of our certificate server. And we're going to use the command line we see here with the dash, so the deploy.ps1 with the dash FQDN, which is now the, oh, I made a typo, my bad. It should be ADCSC.company.com. So it's going to be using the name of the certificates, the connector server, and the dash jamfprodn food@jamfcloud.com, which is the address of our Jamf Cloud server. That one, you could use whatever you want, technically. Shh. And the dash clean install, you can or not use it, it doesn't really matter. So as you're in the PowerShell, it's going to start doing lots of stuff like deploying IIS if it's not already deployed on your server, and configure it. And there are very, very important information. When you execute the script and you get this once it's done, do not close the window. Because if you do, you're going to lose an important thing, this. The client-cert key store password, which is easy to guess, I know, but so if you close the window before taking note of that, you can start again. The good thing is that you can start as many times as you want the installation of your ADCS connector. Doesn't matter. So once it's done, you have in the folder in which is the deploy script, 2 new files, the ADCS-proxy-ca.cer and the client-cert.pfx. And we're going to need these two to configure the connector in Jamf Pro. So now we go to Jamf Pro, we go to Settings, Global Management, PKI Certificates, and we're going to click on Configure New Certificate Authority. And this is where we're going to pick Active Directory Certificate Services, ADCS. And so, a bunch of information here we need. So you can see at the bottom, it says URL or IP address. Never use the IP. Always the name. So this is the name of the server hosting my connector. And then the first two ones, the first one you recognize, pki.corp.company.com, is the address of my certificate server internally. Here I'm lucky. I have a company.com, great. You might have something that is purely internal, like company.internal, whatever. It doesn't matter. Because that address is going to be used by the connector to reach to the certificate server, not by Jamf Pro. So it will work. And the CA name, you can get it from your certificate administrator, admin. It will be able to give you that. I will show you where it is. And at the bottom, we have two things to upload, the server certificates and the client certificate. Let's move on. So the server certificate is going to be the .cer that was created by the script, the PowerShell script. So the ADCS-proxy.ca.cer. That one is used to establish a trust, because the connector is configured, I've said, using IIS, and we're using HTTPS, and we're using a self-signed certificate, that very same one. And we need to tell Jamf Pro, well, when you connect to that server, trust him. Because if we don't do that, it's not a certificate issued by a known root CA, it wouldn't work. And then the second one, the client-cert.pfx, and that's where we're going to need the famous password we had when we executed the script. That one is used to authenticate against IIS. So Jamf Pro, when it's going to connect to the IIS server hosting the ADCS connector, it's not like open bar. You don't get in and you say, hey, give me a certificate. No. You need to authenticate, and you're going to authenticate as a specific user called ADCS Access Proxy user, and you're going to authenticate using a specific certificate that is this one. If you don't have that, you don't get it. Once it's done, great, it looks like this. So you will recognize the name I've used. You see the subject, cn equal adcsc.company.com. The issuer, very same, self-signed. And the client certificate, cnfoo.jamfcloud.com. You remember the Jamf Pro DN in the PowerShell script. And the issuer is exactly the same. We have the same trust relationship. Then, once this is done, you're going to need a few more things. Because you want to get certificates from your certificate server, your Windows certificate server, your ADCS. And in order to do that, you need to say, I want a certificate with that name, but I want it to use that template. And that template, you're going to need to create one. You can't reuse. You can probably not reuse an existing one for very, very specific reason. The third line, subject name has to be supplied in the request. If you don't check that box, I'm going to show you where it is. And you use a standard template that you have by default. All your certificates you're going to issue with the connector will be named with the name of the server hosting the ADCS connector. Which is, well, if you like it, why not, but not very useful. And the second thing is in security. I'm going to show you again. The connector server needs at least read and enroll, either directly or indirectly. Let me show you where it is. So this is the certificate authority app on Windows Server. And we're going to go to the certificate template. Here you see also the name of the CA. You see the company CA. And you're going to click Manage. So right-click, Manage. You get into a completely different interface. You see a bunch more templates. What I do recommend is to duplicate an existing one. Do not try to use an existing one. And we're going to modify it, so you double-click on it for that. And this is where you go to subject name, and you're going to change it from build from this Active Directory information, which is the default for all of them, to supply in the request. Very important. And next step, go to security, and you're going to say, hey, in order to use the template, we need to add the server who is hosting our connector. So in my case, it's ADCS-1. And we're going to add it, and we're going to give it at least read and enroll. Sometimes you will notice that enroll is enough. It's just because we don't see it because I put some red on it, but authenticated users, which is the second line, as read. So the combinations of the computer authenticated is an authenticated user. It gives you read, and then it gets enroll. If you want to be free, if you want to be sure, just check the two boxes. And one other thing you're going to need, in general, is the template name. Not the template display name, but the template name, the one without spaces. Now that it's done, you save it, and you publish the template, because if you don't do that, you can't access it. And once it's published, we will be able to use it. Probably you will not do that yourself, or unless you manage your own PKI server or your ADCS, but someone in your company will ask you, OK, what do you want? Then, how to issue a certificate using that? Well, you go to Jamf, and we're going to create a configuration profile. Here, I created it for computers. It could be also for iOS devices. And you go to the certificate, and in certificates, you're going to create a new payload. And you see that select certificate option, we're going to select the company CA, which is the CA I created in my settings. And I'm going to need to provide a certificate subject to be determined depending on your company needs. Probably a SAN, subject alternative name, again, depending on your needs. And the important piece, the template name that we've seen just before. Is that all clear? Questions so far? Cool. Now, can we go more advanced? Well, the good news is yes. Can we have more than one ADCS providing certificates? It's not uncommon in some orgs to say, oh, yeah, we have a dedicated server for the computer certificates. We have another one for the user certificates. How can we address that with ADCS Connector? Well, we only need one ADCS Connector. It's not linked to anything, in fact. So it's a proxy in between. So how do we create, how do we access pki2.corp.company.com? Well, we're just going to go back to our PKI certificate settings and create a new entry. And we go through the same, very, very same, and we just basically change the name of the PKI we're going to address. The rest is going to be the same. Probably the CA name also is going to be different. But the two certificates we're going to use to authenticate, exactly the same, because we're going through the very same connector. And now we have two PKI, and of course, when we want to create a certificate using a configuration profile, we will have to choose which one we want to talk to. That will be the very same ADCS connector you're going to use. You can also have something like that, where, well, the PKI server is internal, but the ADCS connector, we're going to put that in the DMZ, and we are not using the same domain for both. That with a customer. And there was no way to say, no, they can't have a server in the corp domain that is in the DMZ. It has to be this specific domain itself. Well, the only thing you need, as I said it before, is you need a trust relationship between these two domains. And you can check if there is a trust relationship between these two domains using the Active Directory domains and trust applications on Windows servers, on your domain controllers. And when you open it, you will see your two domains. You can check the properties. And here we can see that we have a trust relationship between the perto.is domain and the corp.it42.fr domain. And I'm going to check the other way. Yes, we have a two-way relationship. One way should be here, in that case, we have two-way relationship. And then we can get certificates, once again. Another advanced setup that I've often had is, oh, another typo. We are using Jamf Cloud, and we have two Jamf Cloud servers, because as the team previously mentioned, you have your server, and you can have your sandbox. Do we need two ADCS connectors for that? Nope. Only one is enough. So you can have, there's no link between the ADCS connector and the Jamf Pro server. Like there can be with Jim. If you're using Jim, you know that there's a very strong relationship between both, because Jim enrolls into Jamf. ADCS connector has no idea what Jamf Pro is. Just received requests from someone that comes with the certificate, say, hey, it's me, can I come in? And of course, you can go completely crazy and have multiple Jamf clouds, well, Jamf server, and multiple PKI with a single ADCS connector. Who's done that? No one? Oh, well, you can do it. Now, a common question I've had is, well, it's great that your ADCS connector is using a self-signed certificate, but we'd rather have either a public one that is publicly trusted, or one that is issued by our internal PKI, because this is our rule. We don't use self-signed certificate. Can you do that? Yes. It's IIS. If you've ever managed IIS, you will know how to do it. If not, let me show you. Now, let's go to our Windows server. And we are going to open something called the MMC and add and remove a snap-in to get access to our certificate store. Click. Yep. And we're going to choose certificates from here. We're going to say we want the computer cert, computer account. And here we see our two ADCSC.company.com and foo.jamfcloud.com certificates that were self-signed and created by the installer. We're just going to import another one that is provided to you either by a trusted authority or internal team that say, yeah, you should use that. So right-click, task, import, and you're going to import the certificate. Important thing, it has to be a PFX or a P12, but Windows, no, sorry, that one is it's wrong. It should be a PFX because we need the private key for that. And we can see that it's issued not by itself, but by the Perto Computer CA, which is one of my internal CAs. Then we go to the IIS settings, and we're going to change the certificate that is used by the ADCS proxy. So you see, we're in, we click on Sites, we go to ADCS proxy, and we're going to click on Bindings, which is on the right side. And in Bindings, we can see that we are using HTTPS on port 443, and we're going to change the certificate, and instead of using the self-signed one, we're going to select another one from the list. It reads from the computer cert SOR, as I mentioned. And you can even check by clicking View, is that the right one? Because sometimes they have the same name, and you're like, which one is which? So double check that is really the one you want to use. And yeah, Perto Computer CA, that's the good one. And do not forget to restart your website, because on Windows, we restart the website. And once this is done, well, now you're using a different cert. Do not forget to change, if you're using a cert that is provided by your internal CA, do not forget to change the first certificate we have in the PKI settings, because we need to tell Jamf Pro, oh yes, trust that one. If it's a public one, you're good. Another question I had, can we use a service account for the ADCS connector instead of the server or the computer account in order to go to the certificate server and get the certificates? The answer is yes, otherwise I wouldn't even mention it. Can we do that? No. Okay, next slide. So in order to do that, we back into the IIS settings, and this time we're going to the applications pool, and we're going to see the ADCS proxy pool. We're going to go to the advanced settings, and because this is obvious, we're going to go to identity in the process model. Why not? And we're going to click on change, and instead of the built-in account, we're going to use custom account. We're going to click on set, and we're going to say we use this username, and it's going to be domain / name of the user and the password. So you need to create it as a user in your Active Directory before as a service account. And once it's done, yes, now we have the Perto / ADCS CSA as ADCS Connector service account. One more thing to do once we've done that, after restarting IIS, is going back to your templates and making sure that this service account can at least read and enroll. Otherwise, the issuance of certificates will fail. Next questions I had. Can we change the authentication certificate for the ADCS connector? So the one that is used by Jamf to authenticate against IIS. By default, it's a self-signed one, but some companies, again, are feeling more confident or better using one that they provide. Of course, the answer is yes. So that would be that part in the settings, if you remember, the client-cert.pfx. So what do you need for that? Well, obviously, you need a certificate. So this is the default one that was created by our script. And where is it stored? I don't know if some of you have ever digged into IIS, but if you go into the configuration editor, and then you go into System Web Server, Security Authentication, then you get to the IIS Client Certificate Mapping Authentication, and you have a one-to-one mappings. Bear with me, we're not finished. You need to click on the ellipsis at the end of the line to open a new window that looks like this, where we can see the one-to-one mappings with our ADCS proxy access user. And you see the certificate? Let me show you. Isn't that beautiful, a certificate like that? Who doesn't love base 64? So we need to change that. Easy. What do we need for that? Well, first, we need a new certificate. And it needs to be a PFX, because the PFX contains the certificate and the private key. And remember, we need a private key in order to decrypt a message that we receive. So ask your manager or administrator to provide you with that certificate, or create it yourself. Get it. Then you're going to import it, once again, into the MMC, into the computer certificate store. We're going to import it. No, we're going to import it, then export it. Sorry, my bad. Can I go back with that? Yeah, OK. So we have imported it into the certificate store. Now that it is imported, we need to export it. Bear with me, you'll see why. And when we export it, we only export the certificate part. I don't want the private key, just a certificate. And it is very important that you choose base 64, not binary. Once this is done, as it's a base 64, it means it's a text. You can open it on a text editor to read it. And we can all see what it contains, letters and numbers. Now that we have this, in order to put that into the IIS settings, we need to do a bit of work. First, we need to get rid of the very first line, begin certificate. We need to get rid of the very last line, end certificate. Easy. And we need to make it a single line. Yes. So remove all the carriage returns. Get a very, very long single line. In my experience, the default notepad can have issues. It can be sometimes too long. I recommend something more advanced. You don't have to do it on the server itself. You can do it on your own Mac or another computer. It doesn't matter. So once you have this single line, you're going to copy it. You're going to go back to your IIS server configuration, the very same place. So we're in the configuration editor. We go to the system web server. So it's a drop-down menu there. Security authentication, IIS client certificate mapping authentication. And we go to the one-to-one mappings. We click on the ADCS proxy access user, and we're going to paste that into the field. So remove the existing one, paste that in there, save. Then you import your certificate into your Jamf server, and voila. Easy. Fine. I'm almost done. I'm good. Thank you. So, a few things to know. When everything is fine, what I really like to look at, it's not that much on the Jamf side, but the IIS logs, which are in C, inetpub, logs, log files, W3, SVC2. And when a certificate is properly issued, you're going to see 3 lines for each certificate. One is a GATE API v1 version with a code of 200, which says, yeah, everything is good. And 2 POST API v1 certificates request API v1 certificate retrieve. If you see these 3 lines, it means you got a certificate with the 200, obviously. If you only see one with a different code, well, we have an issue. Common one I've seen, the infamous 403.16. That is usually due to an improper root CA certificate that is installed in the intermediate folder in Windows certificate store. Some reasons. A good way to identify that, this snippet, PowerShell snippet. So the get child item, blah, 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 will tell you, oh yeah, we found a bunch of certificates that are not in the correct place. Second snippet, move them back to where they're due, where they should be. And try again to issue a certificate. Another error I've seen, and that one is back in the certificate, in the logs in Jamf is that, or in the logs in the Windows PKI servers, that you can't find the template, either because it's not published or because you don't have enough privileges in terms of security to read or enroll using that template. So remember, the server or the service accounts needs, in some way, in any way you want, read and enroll, either directly or because of a combinations of different privileges. Other common issues. We do not have a proper FQDN. So the FQDN for the ADCS connector is what Jamf is using to reach to the ADCS connector. Well, it has to be public. You need to make sure of that. If you don't have that, or try to use an IP, as we are connecting over 443 and HTTPS, means that we're going to see a certificate, and if the names mismatch, boom, it breaks. So even though I know in our interface it says, use IP or FQDN, forget IP, always FQDN. And we're in 2019. DNS has been in use for a while. They work. Do not break the TLS SSL authentication. So I've worked with a customer last week where they had to put a load balancer between Jamf and the ADCS connector, and the load balancer was in charge of the authentication. So Jamf was connecting to the load balancer, authenticating using the certificates, so we had to install that on the load balancer. But then the load balancer was connecting to the connector, and we have to authenticate again. Or change the settings in IIS to say, well, we don't care about authentication, we trust the relay, the communication, but do not break it. You can stop it, but we have to replay it. Another thing that I've seen, GPO on the Windows server that would prevent the usage of self-signed certificate or the authentication of a local user. So check with your Windows admin if there is such a GPO, if there can be an exception for that. And on that, I'm done for today. Do you have any questions?
Thank you. I guess this might have been answered already. I just have a question on whether or not this presentation is available somewhere.
Sorry?
This presentation, the PowerPoint, is available somewhere?
I don't know if we publish them. Do you know,
We will put the recordings up on YouTube and also link to them on Jamf's website once they're edited. But yes,
Okay.
it will be.
Okay, cool.
Yes.
Oh, yes, good news.
Thanks. Is it possible to do like an active-active load balancing configuration for ADCS for resiliency and?
I would be tempted to say yes. The only thing I haven't tried it, to be honest. The only thing I've done with the load balancer was to make sure that we would mainly go to one server, and if it breaks, then we go to the second one. As you've seen, the connection is established in 3 steps. I need to test. I didn't have enough time, I'm sorry. I need to test if we break in the middle, if it still goes on, because at some point the connector needs to retrieve the certificate from the certificate server and store it.
If it's all in one session, it should be okay.
Yeah, yeah. So if you keep the session, preserve the session, should be good. but to be tested for something more advanced.
Okay, thank you.
And it's all IIS. The connector is just an app, so you can do a lot in terms of IIS things.
All right. Yeah.
They make you walk.
And then, yeah, I'll get to you in just a second.
Is it required to have multiple client certificates for multiple Jamf instances?
No.
Or, so that means that the CNAME that's in the certificate does not have to match.
Doesn't matter.
Okay. And if
we usually recommend to make it the dash jam for the end is the name of your server. In one of my tests, I was just typing foo because I was fed up with typing the full name of my Jamf cloud server. It works.
Okay. Okay. And if I update ADCS, do I need to redo all those custom settings?
So as we haven't yet published an update to the ADCS connector, I can't say. I would keep a look on them, an eye on them after an update, but to be determined. Because basically, if we do the update in the way that it doesn't change any of the certificates, it shouldn't break. Yeah. But we haven't done it yet.
Thank you.
There's someone over here, right? Oh, you're good. I'll be right there. I'm coming.
Is it okay to put it on the same server as the gym?
Sorry,
No? Okay, never mind.
Yeah.
Is it okay to put it on the same server as the infrastructure manager? Do you think?
Yes, I've done it.
Yeah? And there's no harm in that? No issue?
No problems at all.
Awesome. That's good to know. Thank you.
Only one server to ask for your infrastructure.
All right, we're going to do one more question just because we're over time, but I've got one more.
Are there any plans to implement revocation of certificates as well?
That's a feature request we have a lot. I don't know if, when and how. I would say go to product management to check with them.
Okay.
But crossing fingers.
Thanks.
All right, thank you, everyone. You've got a 30-minute break. The next session is at 4 o'clock, and that's the last one for today. In this room, it will be deploying macOS Catalina. Otherwise, thank you, Laurent.